Page 3. Our parent function is the square root function. So to draw that, I got to put some axes on there. And the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2. There's going to be my 3 defining points for this graph. Putting units on. And this is the parent. I have only one number inside and one number outside, so there's only 2 transformations. You folks have been wanting to do the inside. It's x times 2. Inside always works horizontally. It's times, not added. So that's going to stretch or compress horizontally. But since it's opposite inside, everything's opposite, so times 2 you would think would be twice as wide, so it's half as wide. Half as far from the y-axis. Since that point is right on the y-axis, it stays there. This point is 1 away from it, so it moves to half a unit away, half as far. This point is 4 units from the y-axis, so it moves to 2 units. And it looks like this. And it's we compressed it now. I didn't know whether you thought vertically or horizontally, so you have to say that it was compressed horizontally by a factor of 2. Or it's half as wide if you wish. And now we got the minus 3 on the outside, which it's an add or subtract, it's not multiplied. So it's outside, so it's working vertically, but it's not a compression or a stretch because it's add or subtracted, not multiplied. And so it's just going to, and on the outside it does what it looks like. So minus 3 looks like it should take it down 3. So down 3 for that point at this half. Down 3. And where it's at 2, 2, it goes down 3, so it's at 2 minus 1. 2 and 2, the units. So it's moved down 3 units. And that would be B. 8. Understand that if you have an even function, if you put in minus 2 and get an answer, and you put in plus 2, you should get the same value if it's even. If you put in minus 1 and put in plus 1, you should get the same answer if it's even. If it's odd, whatever you get for a minus 2, you should get the opposite of that number. So if you got a minus 5, you should get a plus 5. If you got a plus 5, you should get a minus 5. Whenever you put a minus 1 in, whatever you get, you should get the opposite if it's odd. And if you don't get either of those, stays the same or changes sign, then it's a neither. And you can do it with 1, 2, or any number you want to plug in. So we usually pick something fairly easy like 1 or 2. So if I put in 2 into the first one, 2 for the x squared is 4 times 2 is 8 minus 2 is 6. Now put in negative 2. Negative 2 squared is positive 4 times 2 is 8. 8 subtract a negative 2. So let's write it out here because this gets a little confusing. Minus, and we're putting in negative 2. So that's 4 times 2 is 8. Subtract a negative, that's add, plus 2 is 10. We didn't get the same number, and we didn't get the opposite of the number. So it is neither. Let's do B. So we're doing the absolute value. So if I put in 2, and it says absolute value of 0.5 times the x plus 1. So I have to do the inside, all of it first, and then take the absolute value. So if I put in 2, 2 times a half is 1, plus 1 is 2. The absolute value of 2 is 2. Now let's put in minus 2. Negative 2 times a half is negative 1, plus 1 is 0. Absolute value of 0 is 0. Didn't get the same, didn't get opposite, neither. And finally, we have 2x plus 1 squared. If we put in 2, we get 2 times 2, 4 plus 1, 5 squared, 25. If we put in negative 2, 2 times negative 2 is negative 4, plus 1 is negative 3 squared is 9. Not the same, not opposite, neither. If they were the same y's, even. If they were opposite of each other in sign, they're odd. But we got neither. And finally, 9. It says, write a function for the area of the rectangle. Do not think that that's going to stay at 2.8 or 7. This P is any point on this line. So it can move around. It could be down here. It could be up here. So we can't say there's a specific number. So we put in, it's over some value, P is at some point x, y. So the distance over is x. The distance up is the y value. And the area of the rectangle, since I asked for the area, would be, and we want it as a function of x, would be length times width, but the length might be the x, and the width is y, but that's still not of just x, but it says y, f of x, y, is 5 minus x, so we're going to go x times 5 minus x, replacing the y with 5 minus x. There's the area as a function of wherever P ends up. Then it says determine the x where the area is, and that's supposed to be maximum. So we could do that by typing this into the calculator. Go to y equals, clear this out, and go x times parenthesis 5 minus x close parenthesis, and this will give us the area. So I'll graph it, and it says the area is negative until we get to above, x is above 0, and so then we get an area in here. If it was really close to 0, it would be a real skinny one, which wouldn't have much area. The area grows as we move over, then it starts decreasing. When it gets out here, it's real skinny and low. Over here, it's skinny and tall. In here someplace, it's going to have the most area, and that would be up there. And to do that on the calculator, to find that maximum area, we go second, calculate the maximum, number 4 there, and then we have to tell the calculator where to look for it. And I'm going to tell it to look for somewhere between 1 in the x and 4 in the x. So I'm going to say it's between 1, enter, and 4, enter, and it marked here's where 1 is, here's where 4 is. You're telling me to look between those, the calculator is saying. And it says, what's your guess at where it would be in the x? Well, it looks like it's about 2.5, so I'm going to put in 2.5 as my guess. And it says, no, no, I was right on. 2.5, and the area was 6.25. So determine the x. 2.5 is where I get the maximum area. And that's the sample test.